All right, in this lesson we're going to talk about vectors. We're working not out of the book, we're going to work off a packet of questions, and so we'll see that tomorrow in class. So we can talk about a point in the plane, and the point has coordinates. We can identify the point with coordinates. We can also identify the point with a vector that points to that location instead of actually designating the location. We can point to it. And so this is called a position vector. We can write the vector as over 3 up 4. We can write it like this. We can write it like this, or like this, with I with an arrow on top and J with an arrow on top. If the origin is O and the point is A, we could say that this is the vector OA, and we write the vector like that with this is called a column vector, so we say we could represent it with a column vector. Some other notation is just lowercase a with an arrow on top, or a bold A, but that's how it would be written in a book since we don't write like that. When it's bold, it doesn't have to have the arrow on top. Okay, graph the unit vector I and J, the unit vectors, and if you make a dotted line for the axes, then you'll be able to see these vectors. I is +1 and to the right, and J is 1 up. So this is vector I, and that's vector J. Those are called unit vectors. Okay, represent the point using a position vector. So that's what we just did. Go ahead and sketch the graph of this vector. Pause the video. Over 2 up 1, over 2 up 1. There's the point, but we want to represent that location with a vector. So we point to it with a vector, and we could call that vector A. So we could say that vector A is 2, 1. Here's some other characteristics of vectors. A has magnitude, which is its length, and direction. So vectors are a way to describe measurements that have magnitude, size, length, or size, and direction. If there's only a magnitude, then it's not a vector. It's called a scalar. And if we only talk about direction with no magnitude, then it wouldn't be a vector. All right, and go ahead and pause the video, try this one. And in this one, we're going to start at 2, 1, the point 2, 1, and go towards the origin. We can call that vector B, because we call the other one A. Now let's see what the components of this vector are. If we start here, then we have to move left. So that means the horizontal component will be negative, and then down, and the vertical component is negative. Comparing this to what we saw up here, we could just say that if we made this vector negative, it'll change the direction of the vector. So down here, when we change the direction, it is the same as saying that it's just a negative vector. We have a point A with coordinates 2, 4, and a point B with coordinates -3, -5. All right, so here, let's start with the points. And then all right, 2, 4 is A, -3, -5 is B, and we want to go from A to B. We want to represent or find out what that vector is, and we have to look at the horizontal distance. So we're going to go from A to B. We have to move horizontally 1, 2, 3, 4, 5. So that'll be -5 because we moved left. And we have to move down 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 9. Here's a point A and a point B. Find AB. Find the vector AB. Pause the video and try that one. And we have to go from A to B. So vector AB is the horizontal distance 1, 2, 3, 4, 5, and the vertical. Starting from A, we have to move 1, 2, 3, 4, 5, 6, 7, up 7. Now, if we had something like this and we said we want to represent it as a vector or with a vector, this isn't a vector because it only has magnitude. If we say pushing a car northwest, now it can be represented as a vector. Northwest is like that. The magnitude of the vector is 80, so we would say that the length of that line that we drew is 80. And we have the x value, the y value. Since it's going northwest, we have a shortcut here because it must be a 45-degree angle. That means it's an isosceles right triangle. And we know then that x and y are equal, so they're both equal to the same value. And we could just say a squared plus a squared equals 80 squared. 80 over radical 2, and then we could just do, well, rationalize the denominator, and we'll have 80 radical 2 over 2, 40 radical 2. So if we want to represent the vector, we know that they're pushing left, they're pushing west, which would be a negative value, and we're going to go negative 40 radical 2, and then we're pushing north, and that's going to be positive 40 radical 2. And this would be in pounds. And so here, since we have a magnitude of 60 and a direction, southeast, it can be represented as a vector. It is a vector. So pause the video and try that one. That's southeast. We need to know the x and the y. It's a 45-degree angle, and the length or magnitude is 60. So then we can do the same steps. We'd end up with 30 radical 2 because there's a 2 in the denominator. 60 divided by 2 is 30. So we can write the vector as moving to the east, which is positive x, and we'll have a positive 30 radical 2. And then we're moving south, and that'll be a negative 30 radical 2, and that'll be in miles per hour. Let's put a point at 3, 1. That's A. And we'll put a point at 4, 3. B. All right, we want the vector from O to B. This is O, A, B, and we are trying to represent that, OB. We know that we can just look at the graph and know that from O to B, we have to go 1, 2, 3, 4, up 3, over 4, up 3. But there's, we can do this with an equation also, and if we say that OA is 3, 1, and AB, A to B is 1, 2. And that's because to start at A and end at B, we have to go over 1 and up 2. So that's the vector AB. And Then, to get from O to B, we can either go straight or we can go OA plus AB. So we can say that from O to B is the same as going from O to A plus A to B. And O to A is 3, 1. A to B is 1, 2. And we get 4, 3. So we see that you can look at the graph to find the vector OB. You can also just do addition, and that'll give you the same vector. Put a point at -2, 1. And a point at 1, 3. All right, let's pause the video and you find OB by looking at the graph and also by doing addition. So we want to find OB, which is from the origin to B. We can see by counting spaces that it's a 1, 3. It is 1, 3 as a vector. But we can also represent OA and AB. OA is -2, 1. And AB is 1, 2, 3, up 2. AB is over 3 up 2. So then we could say that to get from O to B, we'll do OA plus AB. From O to A, we have that vector. From A to B, we have that. And that sum is 1, 3. So we get the same answer by doing addition that we did by looking at the graph. All right. And we're going to go over 2, 1, 2. The path from A to B. This problem is a little different. Now we want to see a way to do addition to create this vector. We can look at the graph and see that it's a -1, 3. We know we go -1, 3. Let's also look for a way to do it without a graph. So we know that AB is -1, 3. We know that OA is O to A is 3, 1. And we know that OB is 2, 4. And now we're going to use the same concept that we just used here to get from a point from O to B. We could just go straight, or we can add the vectors along the way that get us there. So if we want to start at A and go to B, we could also go A to O and O to B. And that would be a way to use addition to find AB. We want to find AB, so we could say AO plus OB. That is AB. We also saw earlier that when we switch the direction of a vector, it's just the negative of the other direction. So we know that going from O to A is this. So we could say that A to O, to go from A to O, we have the negative of this, because we're going to go left 3, down 1. So O to A is this. If we switch the direction, we'll have the negative of that. We know for this problem, we need to have A to O. So AO is the negative of OA. So, and what we're getting to is a nice formula, simple formula, and that's why right now it's a little confusing. So we have the negative OA. Let's just switch. Let's put that over here. And now we see that to make a vector from A to B, we just have to go B minus A. So OB is given here. The point gives us the vector 2, 4. And here this point 3, 1 gives us the vector 3, 1. And that's going to equal AB. 2 minus 3, negative 1. 4 minus 1, 3. So that's a way to find a vector from a point to another point. We can just subtract their position vectors. And let's just make sure we remember that. If you want a vector from C to D, then you go D minus C. O D minus O C. If you want a vector from E to F, then you go F minus E. So there's the formula. Now one more thing on this. This is a column vector. It also said to represent it in terms of I and J. So we could also say that A, B equals negative I, because that's negative 1I, plus 3J. And that's another way to represent the vectors. Represent the vector DE if D is here. Pause the video and try that one. Here's E. All right, and we need to go from D to E. by looking at the graph, we know that we move to the right, so we can say that DE is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To the right 12, and then we move down 1, 2. So we can find that from the graph. If we want to do the equation, we can say the vector from D to E is OE minus OD, and from O to E is 10, 1. From O to D is negative 2, 3. And the reason why this is helpful is because we can just use the numbers and the coordinates. We don't have to worry about switching signs or anything. OE, you can see it on the graph. We go over 10, up 1. There's the vector. And for D, we go left 2, up 3, 10, plus 2, 1, minus 3. And we'll get the same vector. It's the same as 12I plus negative 2j. That's another way to write the vector. And that's the end.